Namaste. Welcome back to the class. In the last class, we have started the chapter called Sound, and the topics covered in the class were meaning of sound, basic cause of all kind of sounds, vibrations, sounds produced by humans, and also sounds produced by animals. So the topics which are going to be covered in today's class are propagation of sound, propagation of light is faster than sound, few terms of a vibrations, that is amplitude, time period, and also frequency, loudness and pitch of a sound, audible and inaudible sound. Propagation of sound. As we all know that sound is a form of energy which enables us to hear. Sound is produced by vibrations of objects. So in the other words, I can say that vibrating objects can produce sounds. Propagation of sound means a medium is necessary for the propagation of sound waves. The matter, or we can call substance, through which sound is transmitted is called a medium. Means the medium can be in the solid, liquid, or gas. So from this it clearly tells that sound cannot travel in vacuum. A vacuum is nothing but completely absence of matter, that is gas, solid or liquid. Sound wave can travel only through matter. So sound needs a physical medium in order to propagate anywhere. So here we hear sound which comes us through air medium particles. For this, let us discuss one activity. So here we require a small bell jar having a rubber cock fitted in its neck. Drill a small hole centrally through this rubber core. Suspend a small bell jar or bell inside the jar, which we call it as bell jar, with the help of a glass rod. So let the upper end of the rod project out from the hole in the rubber cock and fit this cock firmly in the neck of the bell jar. Close the small opening around the glass rod with a solution so that rubber cock closes the jar's neck in an airtight way. Shake the jar so that the bell starts vibrating, and it also produces the sound which we can hear clearly. Now we can connect the bell jar to a vacuum pump, means which absorbs the air which is present inside the bell jar, and slowly it evacuates the air from it. So we will no longer hear the sound of the bell when the jar is shaken. So we see the bell vibrating, but we do not hear its ringing sound. This is because of the absence of air in the jar, which is removed from the vacuum pump. So this shows that sounds need a material medium for its propagation. So this activity clearly tells us that we could hear the sound of the bell when the air was inside. Therefore, this concludes that sound can travel through gases. Now the question arises, do the sound also travels in the liquids and also in solids? Yes, sound can propagate through both liquids and also in solids. It propagates faster through liquids than it does in the case of gases. Yes, it propagates even faster through solids. So let us learn the activity which shows the sound can also be propagated in the liquid. So for this we have to take two small stone pieces and strike them together. We will hear a sound. Now take a tub full of water. If we press your ear against the tub wall and strike the stone pieces underwater, we will get a sound again. This sound reaches our ear by propagating through water. So this concludes that sound propagates through water also, means which is in the liquid state. So the another activity which tells about sound propagating in the solid. For this, we have to take a long solid smooth aluminium rod with its end well rounded off and smoothened. Let one of the friend keep one end of this rod near to his or her ear and let the other friend strike some other metal object lightly near the other end of the rod. The first friend will then hear a sound, but it may not be heard by another friend standing near him or her. This sound must have then propagated through the solid aluminium rod. Means this concludes that sound propagates through solid aluminium rod also. So the speed of sound depends upon the elasticity, density of the medium through which it propagates. In the case of air, it also depends upon the temperature of sound. Scientists now they are able to measure the speed of sound traveling in air, means which all kinds of gases, and also through water, which is nothing but in liquids. The speed of sound through air is about 330 meter per second, means in air 330 meter per second, whereas the speed of sound in water is close to 1500 meter per second. In air it was 330 meter per second and in water it is 1500 meter per second. Means this concludes that the sound propagates much faster through liquids as compared to gases. Now, people living near railway tracks are well in advance about and approaching the train. The sound produced by the wheels of the train propagates much faster through the solids, that is nothing but in tracks. Therefore, they can be heard and detected much before it is heard through the air. So this shows that the speed of sound in solid is more than that of in liquids and also in gaseous. So this concludes that the speed of sound in solid is greater than the speed of sound in liquid and also it is greater than the speed of sound in gaseous. Light propagates faster than sound. During thundering, sounds are always heard a little after seeing the flash of lightning. This you might have got experienced. During the early stages, people thought that we hear the thunder a little after seeing the lightning because the thunder occurred a little later. But this is not the reason. Both lightning and thunder occur together. The reason for the delay in hearing the thunder is due to the difference in the speeds of sound and also light. The speed of light and sound makes the difference in hearing the thunder and then seeing the lightning. As we all know that light propagates very fast as compared to sound. The speed of sound in air is nearly 330 meter per second. If I tell in kilometer per second, it's nothing but 0.33 kilometer per second. Whereas the speed of light in vacuum is as high as 3 lakh kilometers per second. We know that sound does not travels in vacuum, whereas the speed of light in vacuum is 3 lakh kilometers per second. So, light thus propagates nearly 1,000,000 times faster than the sound. So, when lightning and thunder occur together, the flash of lightning reaches us than the sound of the thunder. It takes a few seconds to reach us. Therefore, hear the thunder a little later after seeing the flash of lightning. The next few terms on vibration, that is amplitude, time period and frequency of vibrations. We have learned that the to and fro motion of an object is known as vibration. This motion is also called as an oscillatory motion, which is nothing but a regular periodic motion. The regular periodic nature of vibration is most easily observed by looking at the swinging bob of simple pendulum. The swinging bob goes only up to a certain position on either side of the central position. This we have learnt in class 7 standard. Thus, we can say that a vibrating body has a maximum displacement on either side of its central position. This maximum displacement of a vibrating body on either side of its central position is called its amplitude. So let me repeat the definition. The maximum displacement of a vibrating body on either side of its central position is called its amplitude. Then comes time period. So before going with the time period, let us look at the swinging bob here. So the maximum displacement on the either side, you can observe there is a mean position, extreme position on either side. So the maximum displacement of a vibrating body on either side of its central position, which is called as a mean position, is called as its amplitude. So if I go with the time period, it is observed that the vibrating body completes its one cycle of to and fro motion in a fixed time interval, then this is called as time period. The next comes frequency. The vibrating body which completes a fixed number of cycles of vibration in 1 second. In 1 second, as many number of vibrations it completes, then that number of vibrations is known as its frequency. So the definition can be stated in this way. A vibrating body completes a fixed number of cycles of vibrations in 1 second is known as its frequency. Keep remember, the amplitude is having an SI unit called as meter, the time period having the SI unit called seconds, then the frequency has its SI unit called hertz, 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 and the abbreviation written as Hz. So here frequency is equal to number of vibrations completed divided by time taken. Then hertz, frequency is written in SI unit hertz, equal to 1 divided by second. The next comes loudness and pitch of a sound. Sound is the measure of sound energy reaching the ear per second. Loudness or softness of a sound depends upon its amplitude, that is, the maximum displacement of a vibrating body on either side of its central position is called its amplitude. So, loudness or softness of a sound depends upon its amplitude. Loudness of sound is proportional to the square of the amplitude of the vibration producing the sound. That is, if the amplitude becomes twice, the loudness increases by a factor 4. Loudness of sound is measured in decibel. The abbreviation for the decibel is small d, capital B. Pitch. Pitch is the sensation of the frequency of an emitted sound. The pitch of sound depends on the frequency of vibration. That is, a vibrating body completes a fixed number of cycles of vibration in 1 second is known as frequency. So the pitch of sound depends on the frequency of vibration. Sound with greater frequency is shriller. Sound with greater frequency is shriller and has a higher pitch. If there is a shriller, which it indicates that higher pitch. Sound with lower frequency is less shriller and of lower pitch. For example, here children and women produce high frequency sound, so their sound is shriller, or we can call it as higher pitch. On the other hand, adult, that is male, produces lower frequency sound, so his sound is less shrill, we can say that lower pitch. A drum produces lower frequency sound, which is less shriller, which indicates that lower pitch, while a whistle produces higher frequency sound, which is shriller, or we can call it as higher pitch. For this, let us have an activity. The activity states the effect of frequency on the pitch of sound by taking a cycle. Make a cycle stand on its support and rotate its back wheel very slowly. Take a knitting needle, touch the spokes of this rotating wheel. Since the wheel is rotated very slowly, so we hear a flat sound, means low pitch sound. If the wheel is rotated very fast, the needle and the spoke produces shrill sound, which is nothing but high pitch sound. This is the case of same in the human beings. The voices of females and children have a higher frequency, means high pitch. The male voice is flatter, which is nothing but lower pitch. Let us go with the next topic, audible and inaudible sounds. So for the inaudible sound, you can observe the left diagram, that is a drum, and strike its membrane very lightly with its hammer. The membrane starts vibrating. If we ask someone who is standing at a distance far away from the drum, can hear the sound? Of course, the answer will be no, because the sound produced in this case is very faint sound, means we are just slightly hammering on it. So the sound here is very faint, so which is not loud enough to hear. So such sound we call it as inaudible sound. You can watch the picture towards the right side. Here we have taken a simple pendulum of about 1 meter length thread. Allow the bob of the pendulum to oscillate. The bob starts oscillating. Do we hear the sound in this case? Of course, the answer is no, because the repeated observations reveal that if the frequency of the vibrating body is less than 20 cycles per second or 20 Hz, its vibrations do not produce any audible sound. Thus, vibrations of frequency, if they are less than 20 cycles per second, again it becomes an inaudible sound. If it turns out that even very high frequency vibrations, that is, do not produce audible sound. So these are the vibrations of frequency more than 20 Hz or less than 20 Hz. We call them as ultrasonics. The human ear thus recognize only those vibrations as audible whose frequency value lies between 20 Hz to 20,000 Hz. So the 20,000 Hz can also be called as 20 kilohertz. So audible range of frequency of sound for human beings extends from 20 Hz to 20,000 Hz. sounds of frequency below 20 Hz cannot be detected by our ears. Such sounds are called as infrasonic, means the frequency less than 20 Hz are called as infrasonic sounds, which are inaudible. Sounds of frequency higher than 20,000 Hz is called as ultrasonic sounds, which are also called as inaudible sounds. Clear? So frequencies having 20 Hz to 20 kilohertz becomes an audible range. If the frequency is less than 20 Hz, we call it as infrasonic sounds. If the frequencies is more than 20 kilohertz, it is called as ultrasonic. So infrasonic and ultrasonic are inaudible sounds to the human beings. Hope this is clear for you, the audible and inaudible sounds for the human ears. So let us know some interesting facts. The whales and elephants produce sound in the infrasonic range. It is also observed that some animals get disturbed before an earthquake. Earthquake produce low frequency, which is nothing but infra sounds, before the main shock waves are released. So it is the feature that possible alerts these animals of an impending earthquake. So ultrasounds are produced by some animals like dolphins, bats and porpoises. Dogs have the ability to hear sounds of frequency much higher than 20 kilohertz, where the human beings cannot hear that sound. Okay. Police teams often use high frequency whistles which dogs can hear but humans cannot. Nowadays, we use ultrasound equipments for investigating and tracking many medical problems. So, this is all about today's class. We'll meet again in the next class, children. Thank you.